This video is on the objective complete the steps of a one mean hypothesis test with population, SD or standard deviation unknown. And this is the critical value approach. Right? Later on in other videos, we'll see the p-value approach also. All right, and this is a one mean t test. Right? Because the population standard deviation, that sigma, is unknown. Right? And remember, if that was the case, then your distribution of the means, sample means for a certain sample size, was a student's t distribution and not a z, not a normal distribution. And this has taken me through all the steps of a hypothesis test, right? So this might take a little bit, right? There's quite a few steps, if you recall, when we did z-tests. All right, so again, if you're unfamiliar with the topic, see how they do things, click on More Instruction, and look at their videos, their examples, their notes. Pardon me, hopefully those help you. All right. So they're based on recent demand for single-family homes in a growing city. It is recommended potential home buyers put 20% down when making an offer. A mortgage loan officer would like to test the claim. Right, there's a claim is being established here, some claim or belief that will be tested. Would like to test the claim that the average percent down on a single-family home purchase is greater than the recommended 20%. To test this claim at the 5% significance level, the mortgage loan officer collects the following data on a sample of 22 recent home purchases and records the percent down. The following is the data from this study. So here's all the information about this person. This mortgage loan officer took a sample of 22 recent home purchases. The sample mean, right, this is the X bar, and I'll write all this down on a piece of paper as well coming up, is 24% down. And the sample standard deviation for these 22 homes is 9% down on the house payment, on the payment toward the house. All right, so we're going to test this claim. Now, I'm going to go to a piece of paper, and let's get rid of the calculator for now, and go through the steps of hypothesis testing. And these are the same steps you saw when we did a one mean hypothesis test with sigma known. But those were z-tests. This time it's sigma's unknown, so we're running a t-test. Right? So part one, right? A claim is made. We identify a claim or a belief that's being tested. Now, this is about a population mean. First, I'm going to state what mu is here. What does this population mean? Mu is the average percent down on all single-family home purchases. This is the average percent, put down on, the population on all single-family home purchases. All right. And the claim being tested by this loan officer, they said that they would like to test the claim that the average percent down on a single-family home purchase is greater than the recommended 20%. So that this average is greater than 20%. So I'll just say mu is greater than 20. Then you have your hypotheses. Well, I guess you could put that in with the first step, because the hypotheses kind of tie into the claim. They're formed based on the claim, right? So then you have to form your hypotheses. All right, there was the null hypothesis labeled H0 and the alternative hypothesis in this text labeled HA. The null hypothesis always involves some sort of equality. The alternative does not. And this claim, the claim does not involve equality. So the claim will be represented by the alternative hypothesis. So the mu is greater than 20. And then the null hypothesis and alternative hypothesis should be opposing statements. So what's the opposite of greater than? It's less than or equal to. So again, this is totally fine for a null hypothesis, but in this particular text, in the Newton Alta homeworks, what we're going to be writing is just what we're going to be assuming. Right, from the null hypothesis, we'll just be assuming that this average percent down is 20%. You assume the equality. So very often this is just written as the null hypothesis, right? That mu equals 20. All right. And again, this alternative hypothesis is where the claim is represented here, because again, the claim did not involve equality. And we can also tell what kind of a test we're performing based on how the alternative hypothesis looks. It is a parameter is greater than some value. So that would be a right-tailed test. Right? So we're performing a right-tailed test. And one-tailed. So later when I go to find a critical value, there's only going to be one of them. Right? Okay. Then after the claim and hypotheses are formed, claims identified, hypotheses are formed, you identify the significance level of the test, and this will be important. Remember the significance level, which was this alpha. This was the area of the rejection regions. Right? And in this case, there's going to be one rejection region, a right tail. Now, it was already told to, in this problem, I read through it, to test this claim at the 5% significance level, it said. So I'll put that as a decimal, 0.05. Now, if the significance level is not mentioned, just assume 5%. That's usually a pretty good significance level for most tests. All right. Then a sample is taken, and information about that sample is given. Now in this problem, the size of the sample was 22 recent home purchases. The sample mean, right, so we're talking about x bar, I'll call it x bar here, was 24% down, right? So we're assuming the population mean is 20% down on a single family home. But these 22 home purchases, they put an average of 24% down. And the sample standard deviation, again given by S, was given to us. They told us it was 9% down, standard deviation for these 22 homes. Now, assuming the population is normal, which isn't a bad assumption. There's a reason the distribution is called the normal distribution, because many distributions have that shape. A lot in the middle, very few above, very few below the average. Assuming normality, normal population, or some population that's approximately normal. Population. Remember, by the central limit theorem, the distribution of sample means for samples of size 24, and this is again sigma unknown, and because sigma is unknown, the distribution of sample means for samples of size 22, sorry, did I say 24 earlier? I meant 22. For samples of size 22 would be a student's t-distribution with so many degrees of freedom. And df, right? Remember, the degrees of freedom for this one sample mean test, one population mean test with sigma unknown was the sample size minus 1. So we're talking a student's t-distribution with 21 degrees of freedom. And the mean of the means, remember, is the mean of the population, which we are assuming is 20. All right, that's being assumed from the null hypothesis, and then later on we'll decide if we like that assumption or not. Are we going to reject that assumption or not reject it? And the standard deviation, recall, of the sample means was, now normally, right, when sigma was known, it was sigma over the square root of n, but we don't know sigma, so we're going to approximate this with s over the square root of n. Right, so 9, our sample standard deviation, divided by the square root of our sample size, the square root of 22, which is, again, approximately, I'll pull up a calculator, so 9 divided by the square root of 22, that's square root of 2, pardon me, typed it in a little too quickly. There we go. So the standard deviation of these sample means for samples of size 22 is approximately 1.9188, so on. All right, sorry, I'll put this over here. Okay, and let me draw a picture. All right, I'm going to draw a picture of a student's t-distribution. Remember, student's t is just like a z, and it's very similar to the standard normal. So you have, the horizontal axis here is t-scores, which are just like z-scores. Symmetrical bell-shaped curve above that. Underneath the peak is a t-score of 0. Right. Now this t-score of 0 corresponds to having a mean of 20. It's like mu equals 20 here. Right? It's like having a mean of 20. Where does our mean come in? Our sample mean is 24. So this is where the the test statistic comes in, and I guess this is step 4. Right? That calculating the test statistic. In this case, it's the t-score, right? Not z-score. The t-score for our sample mean, and I'll write the formula again. It's you take your sample mean, subtract the population mean that's being assumed from the null hypothesis, right? We're assuming that mu is 20. And then dividing it by the standard deviation of the sample means, which is this s over the square root of n this time, right? It's s, not sigma, because we don't know sigma. Alright, so that here would be, I'd take 24 minus 20, and divided by this 9 divided by the square root of 22 in the denominator here. And let me round that to like 2 decimal places. Alright, so now the numerator 24 minus 20 is just 4. So I got 4 in the numerator. And then I already did 9 divided by the square root of 22. That's just the previous answer. So I'm going to put in just the previous answer. And our t-score is about 2.08. Right. Our t-score is 2.08. Which means, again, the middle has a t-score of 0. Here is our test statistic, 2.08. there's the test statistic, or test stat. The question is now, is that so far away from the middle that I'm going to reject the assumption that the mean is 20? Because if this is really far away, then chances are that assumption is wrong and the mean is not 20. Because if the mean were 20 and I took a sample, you'd think it would be relatively close to that middle, right? You'd think it'd be relatively close to 20. But if I assume the mean is 20 and take this sample, and if the mean is relatively far away from 20, then chances are that assumption is bad and we'll reject it. Alright, so this is where the critical value and rejection region come in. So this kind of goes hand in hand with the test statistic. So critical value / rejection region. So I'll kind of put that with the test statistic step. Now again, there's only one critical value here. The reason I know that again is because of this. It's a right-tailed test. So again, we're looking at a student's t with 21 degrees of freedom, right? We said that earlier. I'll draw a picture one more time. T-scores and some bell-shaped symmetrical curve there, and a t-score of 0 underneath the peak. Now it's a right-tailed test, so the rejection region is just going to be in a right tail. So what we're looking for is what's the t-score with an area of alpha above it. Now alpha here, right, the significance level was 5%. So for this t distribution with 21 degrees of freedom, what's this value here? T 0.05. Right? What's the t-score with an area of 5% under the curve to the right of it, above it? This right tail rejection. This is the rejection region. I'll just put rejection. Right. Alright, so let's find this. Now you can find this using a table, which will probably be provided to us as we move through the question. Or, if you recall, did this in an earlier video on this same objective of finding critical values, you can find this with your calculator and that inverse t. So I got the calculator up already. I go to that distributions area, down here to inverse t. Now, this area you're entering is an area to the left. I want 5% to the right. That would mean 95% to the left. So 0.95 is what I'll enter there. And then we said this is a student's t distribution with 21 degrees of freedom. So the df there, 21. Now if you have an older one, you're going to have to just enter this area to the left and then a comma and then 21. This is 1. Let's say 72. All right. So this is about 1.72. All right. So the t-score that is the critical value, the entrance to my rejection region, is this value that's 1.72 standard deviations above the middle. And where did our test statistic fall? Well, remember our test statistic from earlier was 2.08. Where does that fall? Well, that's definitely beyond 1.72, and I'll mark it off here. Here's 2.08. Again, our test statistic. So based on our level of alpha, based on our significance level, our sample mean of 24, right, has a t-score of 2.08. That is relatively too large. This test statistic, our sample's statistic, is in the rejection region. It is considered too extreme, too far away from the center for us to keep that assumption that the mean is 20, for us to keep the null hypothesis. So then comes, I'll call it step 5. Then you make a decision. Now, if the test statistic is in the rejection region, at the boundary or in it, you reject the null hypothesis. So we're going to reject that null hypothesis that the mean was equal to 20, right? So that means we don't like that, and I'm rejecting it. And finally, a conclusion. And of course, if the test statistic is not in the rejection region, you don't reject the null hypothesis. You keep it. And then finally, the conclusion. Now, the conclusion is always about the claim, whether or not you have enough evidence to support the claim. Now, the claim was way back here. The claim that was being tested was that the average down payment, the average percent down on all single-family home purchases was greater than 20%, which was represented again by the alternative hypothesis. Now, I just stated we are rejecting the null hypothesis, so I'm going to scratch that out, meaning that we are supporting this. You got to do one or the other. If I'm rejecting the null hypothesis, that means I am accepting the alternative hypothesis, which was the claim. So I would say that there is sufficient evidence, or I'll just say we support claim. Right? We support the claim that the mean percentage down is greater than 20%. All right. Now they might say it in some fancy way with, the data provides sufficient evidence to support the statement that the average down payment, the average percent down in all single-family home purchases is greater than 20%. They might say it all like that. But as long as you're saying, hey, we're supporting that claim based on this evidence, based on this sample data, that's fine. Right? Just got to make sure you know how to read their sentences. All right, so I'm going to put all this together. All right, that was a lot. Now the first part, they're saying what are the hypotheses? Again, just the null hypothesis that the average is 20. The alternative was the average is greater than 20. Right. You saw me write those earlier. Wonderful. And again, read your answer explanations, please. Then we, of course, have to continue on. We're going to complete all these steps. And then in this scenario that was given, what is the test statistic? Now, and then round your answer to 2 decimal places, which I did. That was that 2.08. All right, I'll pull that back up here. All right, paper calculator, that was this guy here, the 24 minus 20 divided by, it's 2.08, divided by that 9 divided by the square root of 22. So to 2 decimal places, 2.08 is our test statistic, this t sub 0 that they're calling. Again, wonderful. And again, they go through, they show you the same calculation that I just showed you. All right, then they'll be asking more likely now about the critical value. Right. So we have the test statistic. Oh, so this is one of those where you have to move some stuff on a graph to set up the rejection region. So remember, all right, so first the sample size is 22, and it took 22 homes. All right, there you go. Remember, this is a right-tailed test, so I'd like my rejection region to be in that right tail, so this guy here. The test statistic was at 2.08. 2 point... Oh, come on. 2.08. Very sensitive. Okay. And then finally we need to find our critical value. Now the critical value, so they say with the curve, and select the critical value on the x-axis. Now we found this yeah, we have to move stuff. Now find the critical value. Alright, now that was what I found with my calculator. Alright, that was the 1.72. Now I think if I round to 2 decimal places, though, it would be 1.7. Yeah, it would still be 1.72. Right, here was the calculator. Remember this inverse t with 95% to the left, meaning 5% to the right. 21 degrees of freedom was 1.72. Hopefully you remember me seeing this. Me showing you that. So I moved this t here to 1.72. I mean, and then it's obvious, hopefully, that, oh, there it was. No, come on. Maybe if I zoom in, it'll be easier. Oh, there we go. Okay. And you can very clearly see that, again, the test statistic is in the rejection region. All right, so again, down here, reject the null hypothesis. So, or now it's one of these two. Let's read the conclusions. So this first one says, reject the null. There is strong evidence to conclude that the average percent down on a single family home purchase is greater than 20%, and that's what I was saying earlier. That was the alternative hypothesis, right? If you reject the null, then the evidence concludes, you would support the alternative. That's our final conclusion there. This one's saying there's not enough evidence to support the alternative, but if you rejected the null, that means there is enough evidence to support the alternative. So that's what this first one is. That one's the only one that's any good. And there we have completed a hypothesis test about a mean when sigma's unknown, right? A one mean t-test using this critical value approach. Okay. All right, and I believe that's it for that. And yeah, hopefully watching me do this or watching the more instruction that they provide for you helps you out when you're going about doing this kind of problem on your own. And thank you very much for watching.